Okay, I was thinking about bias and variance and overfitting, underfitting. So I ran that scenario that I gave you guys about handling the online retailer, the recommendation engine. This is a little bit more straightforward look at what bias and variance trade-off is. If you're looking at this, you got the complexity of the model, which is just a number of features and the type of features, and you get the prediction error. Now, the dotted line here is the total prediction error. Remember, all you're doing in any algorithm is predicting. And so however far off your predictions are, this is your total error. Notice I go from no features, or one feature out to 10, and then on a scale here from 0 to 12, I don't know how they picked the 12 out, the prediction error. It gets very high, then it dips down, and then it goes back up again. So then you get the blue line, which is your bias. We'll come back to that. The orange line, variance. And then, of course, as you have this particular line right here, this is total error. This is what we call irreducible error, okay, this dotted line here. That's error you can't get rid of. It's noise in the data, random things messing up that you can't see. Every data set has noise. This will vary. This just came out as a straight line because I'm just trying to show the example. This is your optimal point here. What am I trying to do? I want to balance bias, variance, underfitting, and overfitting. Now, you're already well enough to know what's going on with overfitting. I got too many features, so I'm over-specifying. This means that I learned the training data too well, and it doesn't generalize. Your model doesn't generalize to test data. Over here means I've got the wrong model. So this is the balance that you'll see. Now, if you're looking at the scenario, which is
you need an expo marker? I have a few extra.
Carry expo markers?
Yeah, I have a whiteboard in my.
Always prepared. Good.
all right. So assume that you've got this kind of model. You're working a recommendation engine by this online retailer, and the retailer decides on this end that all they're going to do is recommend bestsellers. So I'm over here in bias. Everyone. Okay, this is one end of the continuum. The other end down here is have many customer features. Okay, so there's my continuum. It's not bad, actually. And this, of course, means that you first get started, you say to yourself, okay, I know I'm going to get some hits up here, but I've got high bias because this is clearly the wrong model because you're not including enough information. All right, so you're underfit, you've got the wrong model, but that's okay. The variance comes in when you're looking at, I get the increase in variance. If I start adding in too many features, I get too nitpicky. That's pretty standard what you'll see every time. You could have university admissions. Exact same thing. You're going to have total area up here. What's your bias on university admissions? You're on that committee now. You have to decide who gets into Auburn. A fun job. What's the bias end?
Is there a legacy bias at all?
Oh, yeah. If your parents give a building, you're in. If they're sitting in a box at the stadium for football, you're in.
I'm just talking about if your parents are some smaller level donating alumni, like.
Or that they just came here.
Well, either that or, yeah, they donate whatever minimum.
Yeah, if they're alums, that's a like a little tick. You know, if they donate just a little bit bigger too. Now, what's the deal here on admissions, guys? You're on the committee. You had to go through it. Y'all know all the stuff you filled out.
High school GPA.
Hmm?
High school GPA.
Okay, that's interesting. Suppose that you sit here and you say, okay, on this end, which is high bias, I'm only consider high school GPA. What's the problem with that?
Don't consider the strength of curriculum or whatever state they come from.
Absolutely, the metric for that is 1A to 7A. Every state has them. Little tiny schools versus big giant city schools. 4.2 at Auburn High School is a 7A school, okay, with all kind of faculty kids over there. That's a nerd high school, man. How come we're so good in football then at Auburn High School? Who's the highest paid person in the city of Auburn?
School football coach.
Absolutely, Auburn High School football coach. We're building a new high school in Auburn. What was the biggest sticking point?
How big can the stadium be?
Well, how are we going to use the stadium? Number one, with 2 high schools instead of 1, but how are we going to divide the football players? I don't think I'm making this stuff up. Okay, you're trying to get into Auburn. Here you are down here, and you decide to use high school GPA. Okay, you got the wrong model. Okay, it's too simplistic. So you got very high bias. Well, once I get over here, I get all the stuff that you guys went through when you filled out your application forms. Okay, I wonder if we ran an analysis in any university, if we wouldn't be somewhere in the overfit region. Okay, I've got your GPAs. I know what size high school you went to, AP classes, IB classes, were your parents alums? Are you in-state, out-of-state? Okay, we really want a lot of out-of-staters here because we appreciate y'all's tuition dollars, me personally. Okay, you got to have that balance. Okay, then y'all have to write something. Y'all have to write an essay.
Yeah.
So you did. Y'all didn't have to. Claire, you didn't. Well, Claire used generative AI. I don't know exactly what went on here. But, so think about ACT and SAT scores, okay, et cetera, et cetera. Now, there is there are other considerations that are not mentioned, but my guess is if you were doing that, you're probably overfit. Recommendation engines, if you go through this, and I was thinking about this because you're getting ready to do your Amazon, and you're getting ready to make a recommendation. What's the very first thing you look at?
Past history.
Past history, absolutely. Absolutely. What have you done in the past? If you buy just one product on Amazon, they got your IP address, they know where you are, they started on that. Okay, that's number one. Okay, if that's all you consider, you're here. Okay? Now, what happens if you're down here in your Amazon? You're in a filter bubble. Okay? You like science fiction, you buy a couple science fiction books, they know where you are and who you are and everything. So now, that's all you're going to get. It's not real good for Amazon. Okay? But if you're in a bias situation, they just keep giving you science fiction recommendations. So what do? They throw in a random factor generator and they say, okay, let's give them another type of books or some other type of product. Okay, what are they trying to do? They're trying to move you over here where I think if you were Amazon, would you rather be underfit or overfit?
Probably slightly overfit.
Probably slightly overfit. You wouldn't be totally overfit because that's a computational nightmare. You're going to end up filtering out features. But anytime you're making sales, you probably want to get as close. Y'all know the so-called goal of marketing is an N of 1. So you feel like you're being customized. I think that's fine. But I want you to see this because this is the prediction error model of the one where we were talking about the recommendation engines. Almost all are in this situation. The other thing that you can get into is user ratings and reviews, social media. It's kind of bad when you have whatever your social media texts are being brought into play. If you come down on our original bias and trade-off we were looking at with advertised spend and sales, if you'll notice, we're looking at advertised spending here, and it goes from 0 up to 100. And then I've got the prediction error. In other words, am I predicting sales correctly? Once again, you're always going to have total error up here. Predictions are going to come and go. Here's your irreducible error with just coming out of noise in your data set. Outliers, for example. Bias comes up. Bias starts where I'm spending no money at all. Okay, I'm not spending any money on advertising. All right, then I get variance here. As I start spending money on advertising, then I get a lot better predictions. Well, this is kind of interesting because, you know, when you're looking at the business spend and the behavior here, you've got, you know, too simple a relationship here. So you're underfit. You're overfit here, which means what? You're wasting advertising dollars. Okay, so you want to be right here, as this is one of those places where this is where you want to be. You don't want to overspend, you don't want to underspend, and do we have metrics to do this? Yeah, absolutely. So the optimal spend here naturally 50,000 right in the middle, and based on just synthetic data. And so when you look at this, this goes to what we were talking about. If we had a scatter plot here, you remember the one where we just plotted a regression line, then we overfit it. And then we showed as you increase your advertising spend, the increase in sales, the increase maybe increase a little bit, but it decreases in the speed of increase. So that's all we were talking about. I want you to get an idea of how we look at bias and variance, overfitting and underfitting all at once. So that's the type of thing that everybody looks at, which is harder to handle, bias or variance. Bias. Because you have to recognize you got the wrong model. Okay? And if you have overfitting, that's your underfitting region. If you have overfitting, you can always do feature engineering, which all of we've run into in our examples. Okay? All right. Want you to sit. This is, by the way, if you ever want to do this in a case where you've got any kind of scenario, I did yesterday afternoon, because I was thinking I wanted to show you this example. All you do is you say, tell GPT or Gemini that here's a scenario, okay, and it generated this code. Okay, now I didn't like the graphs, so I played with that a little bit until I got them straight, but that's absolutely no problem. You do not have to write this code. What you do is you give it the business scenario, and it'll produce this. Now, what's interesting is when you get into this thing, if you don't see it right off the bat, like this is the advertised spend and sales, what you do is you come in here and you can prompt the large language model, describe to me in the business scenario what the far left, in other words, what the least amount of advertising spend is. What that means is you're going to not get any sort of the sales that you would, then ask for it to describe the other end. Then what you want to ask is, now describe the business scenario as I move from left to right. Okay, in when first scenario, add features. This one you add advertising dollars. Okay, I'm sure that you guys could intuit that, but if you can't and you get into a model up here where I have to deal with features, then it'll give you the business scenario explanation. Right, so this is the type of thing when you get into Google Drive that you're not quite sure. It actually, what I said, I just said, give me a plot, and then then you just kind of back into it. Now, we'll say we got down here with advertising spend, you're going to end up having to do a little work here with bias and variance with these denominators. Now, this has nothing to do with your projects. I'm just saying when you get it in the real world. The good news is the data scientists will talk to you about that. Okay. It's not something that, by the way, who picks up on bias and variance? You do. Okay. We either got the wrong model, we're not spending enough money, we're not seeing what we got going. Okay, now. That Titanic model, I want to tweak it a little bit. Has anybody looked at that data set at all? You're bad people. Just waiting on me to do it. Okay. You're on the Titanic. You have a Titanic data set, which is very, very, very well known in data science. Okay, it's like one of the ones they always use to, here's how you do a logistic regression. Okay, because just two possibilities. What are you trying to predict? No. You know it's going to hit the iceberg.
Whether you sink or whether you live through the.
You live or die. It's survival. And it's a fascinating study because they've got great data. They're pretty sure who made it and who didn't, but they're damn sure that it hit the iceberg. Okay, well, that's a probability of 1. Survival's another thing entirely. When you go through that data set, I'll give you the weekend to do that since you guys are slackers. Anybody going out of town to Texas A&M? We'll miss you. You're up first on Monday. No, it's just go straight for survival. I think they'll give you a 0-1. I think they actually call it survive, so y'all don't have to pick it out of there. All right, UPS. I really wanted to run through a lot of stuff which we've done before we actually got to a real world case. Now, I doubt seriously if any of you slackers have read this case. Is that true? Anybody read it?
Well, didn't you assign that earlier in the semester?
Yeah, I did.
Assign
I put it off just to see what would happen. Anybody got any recall? Like the great Karnak?
Remember, the business got revolutionized once they focused on their logistical efficiency. Like that was what.
Was it efficiency or effectiveness?
It was too long ago since I read it.
That's right. It's been a day. It's been a whole day. That's right. First question. Is there anything about generative AI in this case? No. This is blocking and tackling. This is what I was talking about. This is all the press, guys, is all about generative AI because everybody's panicked, understandably. Blocking and tackling is where all the action is. Okay. So, first thing, this has nothing to do with generative AI. Now, they may have put a Gen AI front face on it right now, but what their system is, this is all about how to run that company. Now, what process should they pick? You guys, I'm worried about the front row.
It's like a pack of boxes on the truck.
Exactly, that's it.
Route optimization.
Loading boxes on trucks.
Yeah.
That's it. That's all UPS does. That's my Christmas job. Hire a bunch of people to load boxes on at Christmas. Here's the deal. That is a gut level job in UPS. How do you get boxes on trucks? For example, you're now a UPS driver. Y'all know they just renegotiated their contracts, right? They hadn't gone on strike forever, and now their drivers can make up to $170,000 a year. By the way, in UPS, it's mostly privately owned still, and you can't move into management unless you're a driver. Okay, so that's how they promote from within. You watch these men and women run in 90-degree temperatures. You notice their trucks aren't air conditioned. Think about it, if a box that you need to get to first is all the way deep in that truck. They have to pack those things in the sequence that you will be driving in. First drop, first box. Okay, so that's what they have to do here. So they look at this and they say, okay, what does machine learning do? Now this is Eric Siegel, who's an absolute guru in machine learning. This came out of Harvard Data Science Review. It says here, this is his words, Machine learning's value is captured only by deploying it to enact operational change. You hear the word change, you got problems. You automatically do. So, suppose that a data scientist comes up with what they call a viable predictive model but doesn't deploy. It actually works. Okay, your prediction's fine, your recall's fine, and it doesn't work in the organization. Resistance. That is the problem, and that's where things typically fail right there with deployment. They had this gentleman at UPS who came to them out of academia of all things. And so he used this project to optimize trash collection truck routes. How do we pick up trash in Auburn?
Depends on your county.
The trucks, we have a certain day, we walk our trash cans down to the street. Okay? And the trucks follow a set route. Okay? If the trash can's not down there, no problem, just move on. But they follow that route every day for that route. Well, in this county, they did the same thing. So what they decided to do, these students got on this, and they wanted to do optimization, which they did, and they came up, they only needed half the garbage trucks. Now, for a county, that's a huge amount of money. You drive a lot. Well, what happened was, well, they presented this to the officials, and they got the data from the officials, they came back with this, and the officials responded, fantastic. But we never change our routes. Well, what happened was the students had found drivers who baked in breakfast on their routes. They had developed their routines as a lifestyle, not as a means to get their work done. One visited their mother on the way home, another swings by his favorite bakery, et cetera, et cetera. Now, you're a taxpayer in that county. How happy are you? I mean, what are you going to do? If you vote, you can fix this. But then we have to figure out what to do with the drivers. Now, this backs into the case of a very large city in Europe. Y'all have heard of smart trash cans?
Mm-hmm.
They have two metrics, two sensors on them. One, overall weight, two, fullness. Okay, because you can have very heavy load and not be full. All right, as soon as one of those two conditions is met, the trash can holds up its hand wirelessly, hits a central computer, and the drivers know which ones to pick up, which ones not. Okay? Well, everybody says, how do the drivers know where to go? It's different every day. So you guys tell me. Absolutely, you got GPS on your truck. All of you have nav packages in your cars. Only the faculty don't have nav packages. All our cars are too old. But you guys, it just tells you where to go. So when the driver gets in the truck, he or she turns that thing on and goes, head out here, then it tells which one to pick up. They had a third of their trucks. They retired immediately, made a bunch of money, sold them to other cities, and those are called big belly trash cans as a trade name. And the drivers none of them were fired. They were moved to other positions in the city. Okay, what you could do in this county. I just point this out because this is UPS on a grand scale. So I look at the stats. They're looking for package flow technology, which you're talking about, loading the packages on a truck. And it, how would I say this nicely? The model delivered disappointment. It failed. Was there anything wrong with the algorithm? No. Was it correctly optimized? Yes. In other words, did it work for packing the trucks? Yes, it did. So the media caught, this is the Bill guys running this thing. The media caught wind of it, and they basically said, a Computer World headline said, new package flow technology not delivering at UPS. That's cute. Not delivering. Well done. So what happened was, the chief operating officer of UPS chewed up this guy. Now, you guys are all gonna have, big projects like this have to have an executive sponsor. Okay, somebody's gotta cut the checks. If you ever wonder about Leadership 101, this is not it. Okay? Calling somebody in and having a so-called heated discussion of what the case says is a bad idea. Some of you guys are going to be in that position one day. The best way would be call him in and say, what happened? Instead of, you're making me look stupid in the press. So that was very bad. And so they basically ran into people problems. Now, I've got a typical UPS shipping center, which we've got one here in Opelika. 55 trucks leave every morning on average, 300 packages that day. Now that's a driver making about 170,000. If you're making 300 deliveries in a day, you're earning your money. 16,500 packages among the trucks have to be optimized so they can leave on time. What are the limits? What are your metrics? What do you have to meet? What are you trying to do? What are your optimization metrics?
First time, want to minimize time, and you have a maximum limit, of course.
I want to drive as few miles as possible, right? I want to make my route minimized. Okay, I don't want to do any left-hand turns uncontrolled. I don't want to back up if I can avoid all this. And at the end of the day, preferably a regular working day, I want to have all those packages off my truck before I drive it back on. Now, back to the shipping center. Now, you guys have seen UPS trucks at 8 o'clock at night. I know you have. So have we. So you'd like to minimize that. Okay, this is a hell of a job. All right, so I've got these 16,000 packages on average. Now, few miles, few driver hours as possible. Some deliveries are committed for a specific time of day, as you know, plus no driver shift can extend too long. No pressure at all. Okay, now let's multiply that by 1,000. You have 1,000 shipping centers. That's just in the U.S. 1 minute per driver per day, $15 million a year. 1 mile is worth $50 million. Okay, that's the process this guy was attacking. He's going to change it. Billions of gallons of gas, metric tons of emissions. Okay, the trouble is, guys, the system doesn't have complete information. Why? I need information on every package. Why isn't it complete? It's never complete, by the way.
Because it was coming in late, wasn't it? The issue wasn't the issue that they were like some of them were coming in too late and they had to already be packed.
Why would they come in too late?
It was something to do with the addresses that weren't lining up in the system.
Addresses, time zones, international flights on weather, national flights on weather. The packages may not be getting in there on time. They may be incorrectly labeled on the front end. It's a real problem. So it says here, shipping centers begin the lengthy process of planning and loading the trucks before all of tomorrow's delivery become known. Every single day. So you're looking at this and you're going, what's my prediction then?
What packages will be getting there next day or not?
What packages, you're going to have to predict the packages that are coming in. What are you going to use? What are you going to use for data?
I assume you use past data. Just have to include a lot of metrics on whether they came in, like the percentage of packages that come in late or not, and just have to have that factored in.
Absolutely. Look, you're in the process of predicting unknown events based on historical data. Okay, so we're in that future prediction. Well, what's interesting is it kind of blurs into real time when you're trying to load these trucks. So that's what they're going to predict. They're going to change that entire system, and they call that the delivery paradox. You can't optimally plan the truck loading until you know all the deliveries, but by the time you know all the deliveries, you run out of time to load the trucks. So suppose you get an unforeseen last-minute package that shows up, you're out of time, the trucks are heading out, redistributing packages will take too long. So up to 30% of deliveries were still not in the system when the planning for the next day had to begin. There's your prediction right there. That's the process. Overnight flights, missing and partial tracking information, customers late to upload data, and so forth. Whether they call them dumb packages that show up without proper coding, so you have to do that manually. That latency is till today. And so I looked through this and I said, what am I going to do? I'm going to have to do prediction. So I've got to predict tomorrow's package deliveries so it can plan for them based on historical data. Now, all that's bad news. The good news is we're pretty sure what's going to happen around local areas in our shipping center, Opelika-Auburn. Okay. The same thing holds true with all the shipping centers, all 1,000 of them, okay, because they're in a limited geographical area. Now, so there's this package flow technology, and you've got delivery destinations. They can make the predictions. The predictive model generates the predictions. Machine learning learns from the data. In the United States, that's 200 million predictions every night. Now, I get all the probable destinations, those scored as being more than 80% likely, combined with a list of known destinations, and they update predictions every 2 minutes till the trucks head out. So you've got a what? You've got a management console. Every 2 minutes it refreshes. Now, every 2 minutes, that means you may be reloading trucks, redistributing packages. You've got time to do that. That's 30 times an hour. Okay, what time the trucks head out? Just before the sun comes up. Okay, it's early in the morning. You can't leave too early. People aren't awake. You have to leave stuff at the doors. Okay, so you get the picture. By the way, you've all seen your neighbors with packages in the front door, and we all know about door bandits. So what does every UPS driver and FedEx driver have to do now?
Take a
Picture of
picture.
it.
Take a picture of it. Exactly. Proof of concept. Okay, so they got to do all this. Still has to be your time crunch. They've got to do this, and it talks about optimizing brick and mortar logistics. Huge project. The reason Eric picked this one, they're in that kind of mode with UPS. So what happened was this. I'm going to replace a legacy process, which means humans assign the delivery regions, which are called truck sequences, that every truck must cover, done by humans in the old way. So many of these decisions come while loading the trucks, and the staff adjust the assignments in an ad hoc manner based on their experience. Okay, so that's what humans have always done. Think of the truck drivers in that county. That's the way I've always done this. Check in with my mother every day. I go to a bakery every day. Okay. These guys, men and women, are saying, I can reassign these packages based on my experience. That means I'm totally decentralized, depending from one shipping center to the other. All right, now I'm going to centralize that with a new system designed on machine learning based on predictions. Okay, now, just before truck loading begins, the manager of the shipping center completes these final adjustments through his or her console and hopes that no further revisions will take place on the fly. Okay, radically improving efficiency and so forth. Well, get a little problem here, and that is the humans. Those who are carrying out the instructions from the system. All right? If the staff loading the trucks overrode the centralized decisions too often, the system goes away. I've sub-optimized. If you change a package truck assignment, that means it could blow up all the other trucks as well. Delaying trucks wouldn't depart on time. Suppose that the staff overrode the system and put a package onto another truck, they typically would not update the system. Now, physical world, digital world do not align, so you're a truck driver. You got a package, you don't have any idea, it's not on your route. Okay, the other guy, your package is not on there, and he goes to that, he just skips it. So this is a fascinating problem. Now, that's the reason the system blew up. So tell me what you would do. You're Jack, you're in charge of this. It's blowing up because the humans keep overriding the system. How do you fix that? How would you do it? You have 1,000 centers times 16,500 packages per center, which is, 16 million, 160 million? And you are having trouble with your people. The humans are in your way. What do you do? How do you handle this?
Maybe make some sort of penalty system.
The stick. Going for the stick. What about the carrot?
I see that it's an adaptability issue, so maybe like they need to go through some training.
Okay. Who's adapting? The system or the humans?
Humans.
The humans.
Right.
In other words, we've developed this system up in the UPS cloud, the headquarters, and you're having to take all of its recommendations. You're adapting all right. Are you happy? No. What's your worry? What is your worry as a human?
It's wrong.
Yeah, that's your job's gone. The drivers are fine. We don't have bots yet that'll handle this, so they're okay. So, but you're right. The stick works. The carrot works. Adaptability. Well, you have to be very careful here. What are you looking for? You're looking for a win-win if you get it. Okay. So they go down here and they go along. They say, okay. So Jack, who owns the new process, he said the data is as important as the delivery. Okay, this is during putting it in there. Jack and his team would have to convince and reorient staff to follow the plan. Okay, don't move the boxes. Okay. So they're talking about human adoption, change management, which you already talked about. So Jack and his team underestimated the effort required to gain buy-in. Okay? And because of the fear. They're all scared to death, which is fair enough. It really is. Okay, so they doubled down on their change management efforts. At each shipping center, the training team could not leave. In other words, the training teams were blowing in, spending a day or two. As soon as they left, the people were going back and overriding the system, which just blew everything up. So Jack said every training team has to stay there. Now, that's part of adaptability on the training team. You're in North Dakota, man. And you're trying to do change, man. It's cold up there, You're going to stay. Okay, well, here's the metric. The training team had to stay until performance results were attained. Transferring knowledge was not enough. Okay, the staff might be fascinated by the new system, but that excitement could be just a flash in the pan. They return to old routines every time until you figure out a way to stay there. And what you do is the training team, that Jack just said, you're going to stay there until they meet this metrics over a period of time. Okay, how do you reform stubborn creatures of habit? That's all of us. And by the way, you guys out there too, all of you are going to go through this. There's always sheer will and an iron fist. So we have adaptability and the stick. Big change requires some law enforcement. The team supervised, cajoled, I think that means begging, I'm not sure, and even micromanaged a bit. Loaders who struggled to break old habits were reassigned to new areas with which they were not familiar. Okay, Fred, you've been screwing this up. You're going to go over here on this side. Okay, I get it. And they switched places where they would not recognize delivery addresses. So you move to another truck. Okay, so that's the stick. The carrot, they engaged, they befriended, they enlisted. What would you guys do if you really, your first day there, you're the change management team, what would you try to identify first?
Who are the most stubborn, I guess? Who are the most stubborn?
Absolutely. You are going to get one of the ringleaders. Find out who's doing the talking, who's moving the most boxes, and who's talking to all the other ones. You want to identify him or her first. Okay? Now, you got two choices there. You can befriend and engage, or you can move him to another truck. Oh, by the way, the change team, who's in control here? People loading the trucks or the change team? Change team. Yeah, people, you've got it. It's like having a warrant for an arrest. You got the power. Okay. Now they don't talk about people who just laid off. If you get irritated enough, you know. So they did that, and they said, okay, then back to the carrot. They provided incentives in terms of short-term success. Now, by the way, you've just gone through this, you've got everybody on the same page. They're all loading the trucks finally from the system. Nobody's changing stuff around. What's your metric? How do you know that worked out well that one day?
Based on delivery or delivery
Absolutely.
times?
Who comes back? All the trucks come back. A great day would be every truck came back and all the boxes were gone. And the drivers were all on time and you don't have to take any Motrin. That's a great day. So you know, and then you tell everybody, this is great. Bottom line efficiency. Then Jack's team said, well, it would take some time to materialize, and it did. So they put in a scoreboard. Now, y'all know management's balanced scoreboards. It turns out, if you use one, you have to put it on a wall. Big, bold, multicolored, and this truck, red, somebody moved a box, you know, then you get the point. But the scoreboard evidently did the trick. What I get is offline. The change team would take a picture of that every day on their phones. Make sure they had documentation. Because sometimes in the wee hours, the scoreboard would mysteriously change. I know you would never do this, but so they talk about the lagging indicators. Had to explain that to everybody, how the money followed the efficiency. Those scoreboards reported on the staff adherence to improved procedures. Small number of overrides, much more successful, and so forth. Only after a passing grade will the shipping center graduate and the training team leave. Okay, now, you've got 1,000 shipping centers. Who do you start with?
Probably start small at first.
Pick 5. That's what they did. And what's interesting is Jack had a staff, he had a budget. They picked, I think, 5. And then what happened was when those were wildly successful, all the other 995 shipping centers were given these metrics, saying, here's yours, here's theirs. So everybody's going, well, get your training team in here. So he had to staff up. His budget went way up. I think they had hundreds of people as trainers. By the way, one of the things they don't mention here, you got to train the trainers. Okay? If you're a stick kind of guy, they want to talk to you about the carrot. If you're a carrot kind of guy, they want to talk to you about the stick. So you got to be balanced here. Okay, so the tipping point, you know, you would think the tipping point would be 500 of those centers out of 1,000. No, it was the first 5. Because UPS did a great job of publishing those scorecards. And then they would just put them up next to the scorecard you got with the people doing the standard thing.
Was there any strategy in like picking which centers? Like, did they go and pick like a good one, a middle one, or does it say?
It didn't say. I got to tell you, if I'd been Jack and I'd been chewed up by the COO, I might have picked 5 pretty well producing them already. You know, they were at least heading in the right direction.
I was going to ask.
That's just me. Don't anybody publish that.
I was going to ask with those 5, like, do they take into account location of where those 5 are? Because I get starting small, but would you consider?
Just 5 shipping centers, small. They're all about roughly 16,000 packages a day.
Okay.
They've divided that up around. There may be some that are bigger than others.
So would it be more favorable to test in a more urban area or maybe a more?
I tell you what, it didn't say, but I would pick one that was doing pretty well and had limited geographic area to cut down the number of extraneous variables. So then I could scale up to a major center. driving around Auburn's not like driving around Manhattan. We're more spread out, but they're all just trying to fight traffic all day. That's a good question. They didn't say what they did. A typical shipping center required 5 training personnel working on site for many weeks. Evidently, these people are pretty stubborn. It only saved 85 million miles a year, per year. Let's see here. The optimization work continued, expanding truck-to-package assignments and then to streamline driver routes. This came down to prescribed turn-by-turn driving instructions. By the way, every driver has turn-by-turn driving instructions. Every single UPS driver. What are they training?
The future autonomous driving.
Autonomous trucks. Absolutely. Now, here's the interesting thing.
24 hours.
You could go 20, well, yeah, but neighborhoods. Somebody pulls up in my neighborhood, the dog's gonna go crazy. It's 2 o'clock in the morning. And Linda's gonna go crazy. So you gotta sequence these things. But seriously, the autonomous truck, where did the driver go? You still gotta have him or her. Somebody's gotta run the package up to the front door until we get that bot that we saw that was kludgy looking there holding the package out for you. But yeah, the driverless trucks. Then the driver can kick back a little bit. Of course, then the truck's gonna go, wake up, we're here. Put your phone down. But they saved, let's see here, 350 million bucks, 8 millions of gallons of fuel, 185,000 tons of emissions, et cetera, et cetera, et cetera. Now, the point of this case is twofold. Number one, we've got to understand in here all the way through December that blocking and tackling machine learning is big and hairy and scary, high risk. Probably going to need an executive sponsor, but this is people. This is all change management. People, we're affecting people. We really are. Okay. Okay. One day I'll do something on Titanic. Tell me who survived. Okay. See y'all Monday. Have a good weekend. Remember the people we're impacting.